Hi, we are doing section 10.4 today in our note guide, Inscribed Angles. So I kind of started highlighting inscribed angles are when the angle is all the way inside. So central angles were when they came from the center, so in the name. Inscribed is inside, all the way inside. An inscribed angle is an angle with its vertex on the actual circle, with two sides that are chords. So the two sides of the angle are chords of the circle. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. Now, what's nice about this is when it's a central angle right in the middle, the central angle and the arc are equal. So think about if you had a rubber band and you were to pull the rubber band a little farther. Is that angle going to become smaller or larger at this point? So it's going to become a little bit smaller. Imagine like if you had a rubber band around there and you pulled it farther here, it's going to become a smaller angle. The degree of the inscribed angle is going to be equal to half the measure of the intercepted arc. So angle ABC is equal to 1/2 the measure of arc AC. So you either take this and double it, or you take the arc and half it. So it's either double or half depending on which way you're going, so you gotta be really careful about it. Now, if it intercepts on a diameter, right? So the diameter here, if an inscribed angle intercepts a diameter, then it is a right angle. So right here, the intercepted arc, so I did that in yellow, is this arc right here. Intercepted by this is the inscribed angle here. I think when I use the colors, it makes it a little bit clearer. Like that inscribed angle is going to be a right angle because it intercepted half a circle, which is 180. Half of 180, 90 degrees. So the measure of angle BAC is going to be 90 degrees. Now, let's say we have overlapping arcs. So we have two inscribed angles. So I'm still going to use pink for one of them. Let's say we use pink for ABD. Here's my inscribed angle. The intercepted arc is this arc right here, AD. So I'm going to use a second color just to kind of differentiate. We also have this angle ACD. Now, do you see how that angle intercepts the exact same arc? So if two inscribed angles intercept the same arc, then the angles are going to be equal or congruent. So the measure of angle ABD is going to be equal to the measure of angle ACD. Remember, I put that hook through my angle. It doesn't have to have that hook depending on what figure you're looking at or what textbook you're in. Okay, so here we have some examples, 1 through 8. Go ahead, pause, fill those out to the best of your ability, and then come back and check with me. So right here is the arc. If you want to highlight, I'm going to go through and highlight them. I'm going to pause and highlight them for you. Kind of looks like a color explosion right now. But I tried to color code everything so we can see the inscribed angles are pink, the intercepted arcs are yellow, and then whatever we're looking for, I kind of color coded as well, a little maybe different if it wasn't one of those two things. So here I'm looking for the angle and I know the arc. So remember, if I have the angle, I double it for the arc. If I have the arc, I half it for the angle. So I'm going to take 62 divided by 2, and I get 31 degrees for angle WXY. Now over here I have the arc. So what am I going to have to do? Again, pause. Do all of these on your own first. Come back and check. Here I have the arc is 113. I'm going to double it For the angle, I get 226. Sorry, the angle is 113. Double it for the arc. Now here, angle PQR, it intercepts, and I know it's a diameter because it goes through that center. So that means this arc out here is 180. I'm going to half that and get 90 degrees for that angle. Now this one's a little bit tricky. So here I have the angle, I'm going to have to double it for the arc. 47, double it, I get 94. But I want this part of the semicircle. So it's the diameter, those have to add up to 180. 180 minus 94. I end up with 86 for this piece of the arc over here. This one too. What are you going to have to do? I have 53 and 65. All of it has to add up to 360. So I get 53 plus 65. I know that 360 minus 118 times 2 times 4. I get 242 out here. But it's not asking me for that part of the arc. It's asking me for that inscribed angle. So once I have 242, I divide it in half to get the angle, and I get 121. There we go. Now over here, again, I have 3 arcs, but I don't have the arc I'm looking for. It has to add up to 360. I'm going to take 64, 75, 139, 99, I get 18, 10, 16, 17, I get 278. So I have 360 minus 278, I get 2, 55, 8, 82. I get 82 for this arc, but it's not asking me for the arc, it's asking me for the inscribed angles. So remember, once I have that, I'm going to have to divide by 2, and I get 41 because both those angles intercept the same arc. They're both going to be 41 degrees. Okay, so down here, I have an angle and an arc. Remember, you cannot just take this angle, 8x minus 9, and set it equal to 158. You have 2 choices. You can either take this angle and you can multiply it by 2, or you can take this arc and you can divide it by 2. It's really up to you. I am probably going to divide by 2 because it'll give me smaller numbers to work with. So I get 8x minus 9, 180, that would be 79. Add 9 over here, I get 8x equals 88. Divide, I end up with x equals 11. Make sure you're paying attention to what it's asking you to solve for. It is asking me to solve for x, so we're good. Same thing over here. I cannot just say that 67 equals 4x plus 58. I have 2 choices. I can either multiply this by 2 and set them equal, or I can divide this by 2. I think it's easier to use smaller numbers. So again, you can multiply by 2, you're going to get the same answer. I'm going to come over here, I'm going to multiply by 1/2 or divide everything by 2. I get 67 equals 2x, half of 58 is going to be 29. I'm going to subtract this, I end up with 38 equals 2x, divide by 2, I get x equals 19. Again, it's asking me to solve for x, so we are on the right track. I'm going to pause and go to the next page. I'm going to put a sticky note on this page and hopefully come back to it during class. There are a lot of really good problems here, but I don't want to do all of them. So if there are any that you want to see, I'm more than happy to come back and even just give you answers if you want to check them. But there's a lot of tricky things here, like you're going to have to set this equal to 90, you can solve for x. This one, you would have to double this double this to get this arc, and then figure out what this arc would have to be, and then half it to equal that. So this one's kind of tricky. 114, if I double it, I get this arc out here is 228. So I'm going to take 360, and when I take 360, I'm going to subtract the 228, and I'm going to subtract the 78. I have 54 left over for this one right here. So if that one's 54, and it intercepts this arc, I can now half that to get 27 for this. So I'm going to take 7x plus 6 equals 27. I'm going to subtract 6 over here. I get 7x equals 21. Divide, I get x equals 3. It's asking me to solve for x, so we're good. So there are just some tricky ones here. Let's do one more of these. I'll do 11. Well, no, that 11's really similar to that one. So let's do this one here. I'm going to take 67 times 2, which will give me 134 here. And I know all three of these have to add up to 180. So I have 5x plus 21 plus 120 plus 134 equals a total of 360. So we have 21 plus 120 plus 134. We get 5x plus 275 equals 360. I get 5x. Subtract this over equals 85. Divide by 5, and I get that x, which I'm looking for, is equal to 17. So again, take a minute, work some of these out on your own. Let's go ahead and do maybe this one here. Okay, so STU, 5x minus 16 goes right here. SU is this one that goes right here. So again, that 5x minus 16 equals 12x minus 50. They are not equal. You have two choices. I can either take the angle and double it, or I can take this and half it. These are both even, so it's easy to half. If they weren't even, I would double the angle. But because they are both even, I'm going to go ahead and take these and multiply by 1/2. I get 5x minus 16 equals 6x minus 25. Subtract over here, I get x. Add over here, I get 9. So I think I get that x equals 9, but this time that's not asking me to solve for x. I want to solve for STU, which is right here. I'm going to say 5 times 9 minus 16, 45 minus 16, and I get 29 degrees. Okay, so again, I'm not doing all of them, but I did put a sticky note, so maybe we can do some of those in class. We are going to go to the last page for 10-4, inscribed quadrilaterals. We're not going to do all of them, but these are nice. If a quadrilateral, any four-sided figure, square, rectangle, parallelogram, kite, a quadrilateral is inside a circle, inscribed, inside a circle. Then its opposite angles are supplementary, which means they have a sum of 180 degrees, and So measure of angle A and C would add up to 180, and the measure of angle B plus the measure of angle D would add up to 180. Opposite angles are supplementary. All four angles add up to 360. So right here, I know that for quadrilaterals inscribed, opposite angles have to be supplementary. So I am going to take 45, 92, K and M are opposite angles. So 180 minus 45 gives me 135 for K. 180 minus 92 gives me 88 for J. And if I add all four of those angles, they're going to add up to 360. 88 plus 135 plus 92 plus 45, 360. Go ahead and do 3. So what we have to do is 51 is an inscribed angle. Oh, this is tricky. So 51 is an inscribed angle, which means 51 times 2 is 102. This angle out here has got to be 182. So if I take 102 and I subtract the 67, I get the leftover arc over here of 35. Now, I do know that all of the arcs have to add up to 360. So I'm going to take 360, subtract 101, subtract 102, subtract 35. I'm left over with 122. So if I want to look at another arc, let's say I look at this arc here. I'm going to take 122 plus 35. I'm going to divide that by 2. Oh, that's it. Is that right? I feel like something's wrong here. Let's see. Let's see what I did wrong. Let's do it this way. Let's do 51 in W. So 51 in W, 180 minus 51 has to give me 129 here, because they have to be supplementary. So let's forget about what we did here. W is 129. Now if I did 101 and 67, I get 168 for this arc. Divide by 2 to get X is 84. Now I'm going to subtract from 180, and I get 96 here. So what is 9? So if this here is 96, what's 96 times 2 is 192. Oh, I did 102, not 67. Because I had that 102, and I should have added those 3 numbers. Let's try it one more time. 360 minus 101 minus 67 minus 35 leaves me, that's the same thing. Leaves me 157 here. That's not right. I'm going to pause and check that out one more time. No, that's right. So 101, 67, 135, 157. These two, 157 plus 35 is 192. And if I divide that in half, I get the 96. So either way it should work. You've just got to be really careful and really precise with your numbers. Let's do one more of these. Right here, if I want to solve for x, I know that the opposite angles have to add up to 180. I'm going to have 62 minus 5x plus 133 equals 180. I'm going to take 180, I'm going to subtract 133, and I'm going to subtract 62. I'm going to end up with negative 5x equals negative 15. When I divide by a negative, I'm going to end up with a positive. X equals 3. Okay, I'm going to leave some of these problems here as well. So maybe we will come back and do some of these in class. So keep that in mind. That's going to be it for right now. So have a fabulous day. Good luck, and I will see you next time.